Hi there, and welcome to a brand new episode of our webinar called AI-Xplore. And wishing you all a very happy new year. Well, technically, it's still January, it's the first month, so I can wish you all a very happy new year. And also, this is the first webinar that we are doing in 2025. And trust me, we have some amazing discussions that are lined up not only today, but also for our upcoming webinars as well. I'm your host, Atul Priya Sharma, a senior developer advocate at InfraCloud, where I do a lot of things, and this webinar is one of the things that I do. So, this is the fifth episode of our AI Explore webinar, and today we would be discussing about building AI systems. For those of you who don't know, outside of work, I'm a big time foodie and a food blogger. So, whenever I'm free, I'm at a restaurant trying out some new dish. And I'm coming from a city called Hyderabad in India. And this city is famous for its biryani. And biryani is a dish that has a lot of complex elements in it, right? You need proper ingredients. You need the right amount of rice, right quality of rice, the spices, the meat, the aromatic. And each of these has to be cooked in a perfect proportion and then combined together. And building AI systems is exactly like that. So today's webinar will be about that. And before we move on to the juicy discussions today, a quick recap on the previous webinars that we have done. So we have discussed in the past about building your own AI lab. We spoke about how to observe your AI systems along with a lot of other topics. So all you have to do is scan this QR code that will take you to our YouTube page where you can watch our previous webinars. With that out of the way, I think it's extremely important to invite my guest for today's webinar, two amazing people I've had interactions with. And let me bring upon Craig, who is joining us from Cloudflare, and we have Aman, who is joining from InfraCloud. Hey, Craig. Hey, Aman. Thanks for joining.
Hey, thanks for having us.
Great. Good to see you all.
So excited, and now I'm thinking about biryani the whole time. I'm going to be thinking about biryani.
If I was in your city, I would have definitely, sent one to your doorstep. But yes, maybe next time you are in India or I'm there, we are meeting on a plate of biryani.
Awesome.
So,
Let's do it.
so Craig is the first time he's making his first appearance on this webinar, and a lot of you who have been watching our webinars, Aman is a regular person on these webinars. So we have a tradition where I ask my guests to introduce themselves because I fear that there might be chances that I might miss something and my guest can get offended. So Craig, why don't you go ahead and introduce yourself to our audience? Tell us who you are, what do you do at work, where are you based out of, and some hobbies outside of work.
Okay, awesome. Yeah, sure. So I am a developer educator for Cloudflare. I'm based in Portland, Oregon. I focus on our AI products, and so developer educator is one of those things where you're like, well, I educate developers. That's what it's like. The title kind of says what it is. So whatever that means, right? So I like what you said there, Atul, where you said that you do all sorts of other things. So whether that be video or docs or writing code samples and that sort of thing. So trying to make sure that everybody can get up and running on Cloudflare, on the Cloudflare stack, and on AI. I have hobbies outside. I like to do. I'm into comedy. I've done some stand-up comedy, some improv. I'm trying to get into some sketch writing now. So that's kind of an outside hobby that I have. I like to rock climb too. There's two. We got two things there. And I also like to eat biryani. That's also a hobby that I have. So very happy to talk about the complex systems.
Wow. There's great, things that you've been doing. Obviously, love your interests. Let's see what Aman has to tell about himself.
Hey, thanks, Abdul. Thanks for having me here again. Yeah, so my background, I'm working for the last 12 years, mostly in cloud native container systems and all. I've seen the overall evolution and worked quite closely in these areas. And like many of the architects in the industry, I am the last 2 years doing AI stuff and trying to just get some knowledge out of it. Yeah, that has been mostly my experience. Apart from work, I am quite opposite to Craig. Pretty boring. I just read books and watch Netflix. That's all I do. Yeah, the only thing common is I also love biryani a lot. Can have it daily. Yeah.
Perfect, perfect. So I think this is going to be an exciting webinar. We have three biryani lovers with one AI expert, the other one AI pro, and the third me who's still trying to get to speed with what's happening around. So, before we get into the actual discussion, quick housekeeping stuff. First of all, do let us know where you are joining in from and whether you are a biryani fan as well or not. Drop in your comments, whether you are on YouTube, whether you're on LinkedIn or StreamYard. Let us know where you're joining in from and what do you do. And we would be taking in questions from all of you. So at any stage you feel you have something to ask, please feel free to put it in the comments. I will take it up with the guest either during the webinar or at the end of it. Now, with that out of the way, I think it's high time we get started with the meat of today's discussion. And that's comparing AI versus traditional systems, right? So all of us have been, working in the software industry for quite a while now, and we have seen the entire landscape change quite vividly and quite quickly, right? Uh, from absolute beginners where we were probably working on with monoliths, right? Just have one single piece of code doing everything for you. And then suddenly cloud native coming, you have microservices, then your apps are now distributed globally, and then APIs, and a bunch of whole other things. So the way the entire transition has happened, I think a lot of us have handled it pretty well. But then the systems have changed quite a bit, and I think that's where I would lead into my first question, which would be to Aman, and that would be more around to understanding that how are AI systems different from traditional systems, and what are some specific requirements that are absolutely necessary to build an AI system?
Sure, sure. Yeah. So I think you're pretty much very well summarized the traditional systems, and it's like industry knows it all about it now. There are multi-tier systems, there are databases, the patterns, bunch of books on design patterns and whatnot. But what has changed now is with AI, everything is about data. So if you have experienced Gemini now coming out in the last 1 month, you might have seen it coming everywhere on the Google product. It is like on your mail, it is on your Google Docs, it is on your sheet. And what does it actually work on? It works on the data that you have on that particular screen. So that's what all the AI systems basically need. And when I say about this is just the input of it. Now, when it comes to relating it, when it comes to, hey, I want to put my domain knowledge to it, my company knowledge to it, it's another layer of data. And when you query it, like you must have seen on ChatGPT or Claude that you make queries continuously, and after 10 or 6, 10 or 20 iterations, you will see Claude showing a message that reduce the chat, your chat size is increasing, it's better to create a new chat, because it has to memorize all those things. So a lot of data goes in getting one output good, and that's where AI is all about data. Now, when we have this much data, the problem is how do you scale, right? You can definitely follow the traditional practices and replicate it, have more instances of servers, and you can just scale it. People might say that Kubernetes and all these are already cracked things, right? You know how to scale. But the problem is these hardwares; these are not yet those easily accessible or that that more cheaper compared to the traditional compute VMs. That has gone considerably to the lower prices, but still GPUs are very, very, very costly. You cannot say that I can just run my entire systems as like oversubscription of 1x, 2x. You cannot do that. You cannot afford that. Your complete product pricing will change based on that. And lastly, like you mentioned on the traditional systems, you have different patterns. Whenever something fails, you get a particular error code that, hey, 404, your server is not performing well. 505, your server is down. 30, something redirecting. This is all well defined. But when we're talking about AI or LLM models and all these things, the first part is it will always respond, but you don't know it is responding right or wrong. So there is a validator that needs to be there. Now that validator can be in multiple fashions. If you're just doing a chat, you are yourself a validator. But if you are running a product, you might need like a code validators. You might need language validators. Multiple things you need before even sending out that code. So there is no standard pattern that has been achieved on this. So that's where it's complex. Like how do you do that? And how when people talk about like I'm adopting AI infrastructure for my product, but how these things, you'll have to think about it when you are doing it, because this is going to change. It's not like traditional microservices that I'll just put this, I'll put that, I'll get this error code, I'll redirect. It's not going to work in that way.
Yeah.
Yes, that's absolutely interesting. One thing, Aman, that you really mentioned was there is no standardized way. When you are probably building a system here, right? A lot of different things, like you pointed out, your data, your resources. Especially when it comes to inference and training. Obviously, your hardware, GPUs, and then the traditional way of handling errors or patterns would not probably work. Now, taking this to the next level, we spoke about the infrastructure layer, but then there are a lot of components that are built, on top of it. And Craig, why don't you, tell us what are some core components that are part of an AI system, which absolutely differentiates it from anything else?
Yeah. So for sure, you need, right. So we have models, right? We have different models that are out there, and they change, right? So on top of what you're talking about there with like watching the error changing there, you also have models that models are typically broken down by a specific task, right? And so you might be using that model to solve a task, and a new one might come out, and now you change that, and now you have a new error. You've moved your problem there. So they need to be. I believe that's what we're talking about here. What we're talking about with a specific version control of it. You have a certain version of this model that comes out that works differently, and might even the place where you're hosting the model might the way that you're hosting the model might make it behave a little bit differently as well. So one of the things that we do here is you can watch how your users are using things, because over time too, you want your AI system to get better, right? As people use it, you want to watch what they're doing, and are they using it the way that you intended to do it? So that this last bullet here, this advanced monitoring and observability stack, that's something that we lean into. At the end here, I'll do a little demo of how we do that here at Cloudflare. We have a tool called AI Gateway that lets you watch the stuff as it's going in, and lets you build evals from that. So you can say, did that work? And if that did, and then you can go and you could take that, you could build a training set for that. So
interesting. Yeah, I think the point that Aman and you highlighted about observing, and I think what you really mentioned about the phrase that you used was basically, are your users actually using it the way you want them to use, right? I think that's very critical, because when you are building something as a team, you are doing it for one particular thing, but then eventually when it reaches your customers or end users, it might be used in a completely different way. And I think that's where your entire monitoring, observability, and even the validation steps would come in, because eventually you don't want something to be sent to your users which was not supposed to go, right? You don't want to be in a soup, especially today when everything spreads like a wildfire on the internet. You don't want to be in soup for any reason.
Yeah, and a lot of these models end up chaining together, right? So a lot of these tasks are, so you take the input from one. We're talking about heavy IO, so you take the input from one, and that creates output. And you take that output and you put it someplace else, and it's got this really rich data pipeline as you start thinking about that. And at any point in that can break, right? Any point in that data pipeline, so that gets challenging as well. And how do you watch that and all that sort of stuff? So
absolutely, I think the way you mentioned it was simply like calling one function to other function and sending output from one function to other. But then in reality, we know how difficult it is to maintain such a huge pipeline with so many models, inputs and outputs, flowing between them. Now, while we spoke about the technical aspects, we focus on the infrastructure as well as the core components. I think there are absolutely, you need to consider business aspects of it as well, right? Because while technical things are in place, you want to be quick, to release the features. You want your customer success stories to come out really well as well. So Craig, what are your thoughts on some absolute necessary considerations that teams or businesses should have when they are adopting or building an AI system?
Yeah, I think that latency is a big part of things. So we've come up with the ability to like think about we've come up with some places where the user's kind of waiting for something to happen, and then there's like these back-end tasks as well that can happen. And so as far as like thinking about how is the user interacting with this AI system, that's there on the front side of that. When you build that, you need to build the AI systems that allow people to be able to build those applications, right? So like that's kind of where our head's at. It's like you need to have, it's hard, right? So one of the things that like getting this stuff up and running is hard and challenging. So you need a team of people, right? You need a team of people who are dialed in and understand how to make this scale, right? Because the cost scale, right? So you need to figure out how to make this scale and how to make it scale. I think one of the problems that I haven't seen touched on too much is the global, how global this needs to be, right? Like while it might be really great, if I'm hitting US East 1, that looks really great, right? But if I take that and I go to Hyperbad and we're there, is it great? Is that like the latency there is important? And that's something that we've always dealt with at Cloudflare. I don't know if people know, people probably know who Cloudflare is. We have over points presence in over 330 cities. So like, we are thinking about that, but that is hard, right? Like getting that there is hard. So getting the GPUs out there is hard, and having the infrastructure to be able to build on top of it is also hard, right? So yeah, I'll let you talk a little bit there, Aman. I've been stealing the mic.
Yeah. I think infra costing, estimation, right sizing, that has always been a concern, even in the normal traditional services world. They always have to do the right side. But the only challenge here is, I mean, if we skip the last 5 days or last 10 days, when the world turned into the red, it was still costly to run any model. And in the last 10 days, we only know that there are models that can even run on the smaller systems, that can be trained on smaller systems. But yeah, this space is evolving. We still don't know whether this is certain or not, how much, but whatever is out there, you still need a lot to run models. And your time to market for any product to launch, be successful, it really needs a good infra. It needs to attract audience. When you attract audience, you have to have more infra. And this is not easily accessible. So that's where your infrastructure maturity. And even if you acquired it, you need to design it in a very good fashion. Like in our previous webinars also, we spoke about when you are having these GPU machines in your data center, it's not as simple as a traditional compute. Traditional compute usually have to run good on 10 Gbps network. That's fair enough for them because they don't do a lot of shuffling between the systems, right? But when we talk about inference parallelism, like pipeline, tensor, a lot of data needs to move across the machines. And you cannot sustain with 10 Gbps. You might need like better 200 gigs of lines. You need smarter switches to do that do network level of offloading for you. So that's where the entire infrastructure maturity has also changed quite a lot with traditional systems. And people used to do MLOps practices. It was there earlier, but like in a very niche domains like computer vision, speech, text to speech, speech to text, and those things. They were very well-defined models. They were very well-defined things. But now everything has become natural language. And when it becomes that, it means just the same example as Gemini. Similarly, it will happen for many other products. You will see models just jumping on the screen everywhere. Whatever features you have, people will like to offload it to make it easier in natural language. And that's where your normal operations should also be enhanced to like more of ML operations. They need to know these things, how they tie up. And all this boils down to the fact like how much accurate you want to be and how much cost you want to burn. And that's where it on the cost of being accuracy, can you acquire like 1,000 GPUs? Might not. So that's the trade-off that you have to get to.
Right.
Interesting. There are some really, really good, comments from both of you on the business, side of things. And considering that all three of us are foodies, and I have two more foodies in the comments who love biryani, it's fair to relate this back to a McDonald's burger. For example, I think when they made the hamburger in the US, they would have thought that okay, it works over here. Whether you're in LA or New York, you get a standardized McD burger. But what if we are going to India? The hamburger might not be a success there. So how would the application or the burger rather, be there? So, you customize to that location, you reduce the latency. So even here, we get it in like 5 minutes or a couple of minutes. So I think that the same analogy, comes back to, the models and the entire AI systems as well. So having looked into the core aspects of it of a typical AI system and understood what are the various base level requirements that is necessary to build a system. I think it's evident and more important and more logical rather to talk about the building blocks of a particular AI system. And a lot of us are seeing the vast changing landscape of AI LLM models. You have a new model coming up almost on a daily basis. You open your eyes and you have a new model who is beating the benchmark left, right, center, right? So these models are obviously essentially the core of an AI system. But then as I understand it, these are just one piece of the puzzle, and it is very essential to understand how you are going to build something out of it, build something more useful, and then take it to your end customers, right? How are they going to benefit from whatever LLM you're using, whatever benchmark you're beating, so on and so forth. So Aman, what are some core requirements in terms of building blocks that are absolutely necessary to start or to build a AI system in place?
Right. I think the first things first, the costliest piece there is the GPU cluster. So you have to be mastered in that, how you are managing it, how you are scheduling workloads. I think last 6 to 8 years, I think people have been more used to Kubernetes. And anyone who has used Kubernetes would always love to handle the scheduling, offload the scheduling part to the cluster. And that's what people's expectation is turning out to be in the GPU as well. Hey, I don't want to marry to a GPU. I just want a GPU where it is. That's fine. It should be part of my cluster. So an efficient management of your cluster and scheduling is very much essential. That will considerably increase the productivity of your entire team. Now, like I spoke in the last day as well, the high bandwidth network, that's a new requirement, to be very honest. It's more of like, it was never there. It was there for like very specific set of systems, but now it is becoming more common. If you want to use, if you want to perform, if you want the models to be performed in that way, and your all GPUs should be utilized effectively, uh, you need to have a good bandwidth network, at least within your data center. What goes out in the internet, nobody can control, but at least in your data center, you should be able to control it. Now, critical things are like models, like you said, is not the only data. You have your company domains. I think you can create vectors out of it, embeddings and all those things. You need to host it somewhere. That data is there. Then you have, again, traditional systems analogy. You have caching layers, same in the models as well. Where do you store that? How much you can put on the system, how much you can put on the distributed storages, what you need. Again, if I say distributed storage, that doesn't mean that you can offload it to a normal S3 or an NFS. That might not fly. Because when your model runs, you expect it to return like in seconds. That is what people expecting these days when they hit a query to ChatGPT. That's an addiction that ChatGPT and Claude has created to the people's mind. So even if you host your own model, you want it to perform like, hey, I've given you a test, you just analyze and give me everything in 1 second, 2 seconds. For that to happen, model has to access data even in milliseconds. And that can only be possible through advanced distributed storage technologies. And that is highly dependent on your network. Again, high bandwidth network ties to it. And like I said, scheduling is something that people are addicted to Kubernetes, and that's where your container orchestration again comes in. At least that takes out the part of, hey, I tested this on this machine, you cannot run it. Those things are gone. That's an old day now. So you can continue the same tradition here. Build your ML workload as a container, deploy the entire your infra. You can test it across the infra. All things changes, like you might get new GPUs, you might have to revalidate. But other than that, your code is boxed and everything is reusable.
Yep.
Yeah.
Craig, anything you want to add to this?
Yeah. I think the GPU, like we talked about, the GPU is expensive. That's an expensive piece there, and you want to make sure that you're also utilizing it the best that you have because you made this investment, right? And so like that's something to really think about as you're trying to figure out how to schedule. Something that I don't often have to deal with because like we do that, but I hear the team talking about that, about like we have these GPUs and how do we make sure that they're all being utilized. And if you have it on the globe, right, you can. There's parts of the world that are asleep at certain times. So you can possibly, if it's a long running task and it's not one of those things that like we talked about where you're expecting it to come back right away, you could probably route things that way, right? And try to light up all the GPUs, try to make them all go burr at once. And if you're doing that, then you're doing it. But it's hard. It's really, really hard. Like I watch the struggle of making people do this, and I'm super impressed. I'm always impressed by ML ops teams of how great they are at thinking through this new problem, right? Because this is a new problem of like, this is this very expensive thing that we need to fully use. So
respect to MLOps teams, and I've been someone who have been working closely with platform engineering as well, and I think that's where I feel when you have a platform, it takes care of a lot of things which is essentially abstracted from developers, right? So we don't need to worry about how my workload is going to a particular GPU, or whether the resources are being used in an optimized manner or not. So I think you very well pointed out. So if there is any MLOps person in our chat, hats off to you and your entire team for taking care of the entire MLOps pipelines that we have in place. So yeah, I think both Aman and Craig pointed out really nicely the core components. You obviously have the hardware and the GPU. You have the network, which I wasn't aware of, that how critical it is when it comes to ML systems. And then obviously storage as well, something which is quite neglected, and obviously your orchestration layer as well. Now, once we get into design, right, when you have these core requirements, all of these cannot work independently, and all of them have to come together. And that is where you get to figure out, or rather understand, how do you want to place all these systems together? The basically understanding how the entire system should be built using these components to give you the desired output that you want. Craig, what are your thoughts or insights on how do you bring all of these components, and what are some intricacies that one should understand while they are building such systems?
Yeah, I love we're starting off here. We're talking about the event-driven pipeline, right? So there's a lot of things that happen, and then you want to go do a thing. You want to go kick off a different AI model. You want to kick off a flow that uses an AI model and I think that is using a queuing system or something along that line. Some sort of event-driven thing through queues is a very good thing to think about, and we're seeing those patterns arise. I'll show a demo of that here a little bit later too. Yeah, and then along the lines here, right, of sometimes models go down, right, and you're relying on these. You're relying on some, maybe you're relying on a state-of-the-art model, and maybe your model goes down and you want to flip it to a state-of-the-art model when that does go down. So that is a pattern that's real, right? And another thing that happens, like not only can the model go down, but the model can be updated. So some of these you're pinned to a model, and we talk about these version updates, and a version update happens, and all of a sudden the code that you've written as a developer has changed there. And so you need to switch that really quick. So I think that is a pattern of adding this layer in there, of making sure that you're able to switch models when one goes down, or fall back to another model. So I think along the lines of that the circuit breaker pattern is there in it's a bit of a new abstraction, I think, called like a gateway. It's kind of where people are calling that at here. I think that's what we're after here on this. But if we're talking about that from a ML side too, I'd love to let the ML that happen. But that on the dev side, that's kind of where it's at. I'll make sure I include a little bit of how we think about that there, so we can kind of walk through that when we do a demo here later.
Great. Aman, what are your thoughts? Because I know that you have been involved in some discussions at InfraCloud as well, architecting some larger systems. So anything that you would want to add to this?
Yeah, so I just add to the point that Craig mentioned, models can go down. And the classic example, if you have been using Claude actively, one time a day, you will definitely see a message that we are overbooked right now, and switching all the requests to Heiko other than Sonnet or Opus. Yeah, so they do that. I mean, even at running at such a good scale, having such a good infra, they also get overbooked. I mean, there are tons of requests coming, and same patterns apply to your systems when you design it. If you are hosting a model, you cannot rely on it. Like your scale of product users can increase from 100 to 1,000. Let's say you are doing an event. Your model cannot handle it. You might have not tested it that well, but you need to have a circuit breaker that, hey, switch it to at least the lower version of it that can still give responses, not so much accurate, but still will handle that. We have designed a system for that. So that is something like typically come from the traditional microservices architecture, but you still have to have there. And service mesh is always like a two-edged sword. You have it, you don't have it. There is pros and cons.
There's always something.
It gives you visibility
about it.
Yeah. So I'll not do too deep into that. It's good to have, and it's even not good to have. So it's a customer's decision.
Interesting. I think really good insights coming in from here. Just like in life, all of us should have plan B for everything. I think when you're building AI systems as well, you need to ensure you have a plan B, plan C, plan D as well. Because you don't know, someone just goes ahead and puts a video about what your application is, and suddenly you see a spike that now you have 100 million people just accessing your service, and you are just sending them error 500, something of that sort. So you don't want them to happen. And that is where it's very crucial to understand what your needs are, what your customers are looking for, and then decide how you want the system to be, in place. So now, having discussed the system, I think, as a typical software development lifecycle, you go from high to the lower level. I think the next important step is your actual design patterns. How do you get into the lower level modules, lower level constructs while you are building an AI system? And I think the expert today for these design patterns is Craig over here. And I got him here just for this because, he has been doing things left, right, center, and spent a lot of time on identifying best practices around how to design, the low level constructs. So I think, Craig, I'll just leave it open for you and go ahead and, share your insights with us.
Cool, great, yeah. So there's these models are based on tasks, right? On tasks that they can do, and it's very the state of the art models can actually do a lot, and you can go and hit the state of the art model. But it is important to remember that there's these smaller models that are very specific to a certain thing. So you might want to think about using those instead of making the larger model go and do all of the work. So you could think about having different models, and that gets into a design pattern, right? If you're I'm going to break apart what I would have done in a large statement hitting one of these AI models into these smaller bits and kind of chain those together. And then also what that allows you to do is you can maybe do some batch processing like that we were talking about in the previous one, because these models are smaller and easier, and the output is more specific to what you're really looking for, instead of having to going and building things around that. So that's something. All of these have a very RESTful API, a lot of which is really nice, right? So like we've abstracted away this ability to touch these models with this REST API, and it will stream, right? So it'll stream out, especially in the LLM models, stream out the context to you because we want the users to feel like it's being updated, right? So I've been loving lately how the reasoning style model, where it's like taking a little break, like I'm gonna think, because this is important stuff. Like so the thinking style of that, but you'll see that it's still streaming what it's thinking, right? So we're always trying to send back those tokens as fast as possible. And that's just where we're at right now with how things are working. And the models are updating, right? So we want to make sure that you're pinning the model to the right thing. So because models change, right? Models are trained on different things, and the way that you might be expecting things to work can immediately change if you don't have that pinned. And the pattern, this stateless inference service, as you do a chat, and we talked about this actually a little bit earlier, as you do a chat, the chat grows, but I'm pushing the chat each time to this. To that same RESTful API. So the chat's growing, like these messages array is growing and growing, and I'm shoving that in each time. And so that you need to figure out how to handle that properly too, right? So, but that's kind of the main pattern for that is you're oftentimes not even storing those messages, you're pushing them each time into there. And sometimes that might not be the best way to build stuff. Maybe the best way to build stuff is to take it on the other side and store a little bit of state, right? And work through that. But we see this a lot. Like if you're using these models, you are pushing up your context each time of what you're doing and what's on your, and that can be expensive, right? That could be expensive and also hard to manage and think about. Like, oh, what if they use this for a half hour, right? Like, I think a lot of the use cases we start thinking of like, okay, cool. So they did it for 5 minutes, we're good. But like, what if this is a long running thing? How do I summarize this? How do I get the most core part of this? Because you can only push so much context. I know that our context windows have like grown like crazy, but you can only push so much in as you're going. cost effectively too. So then you need to start thinking on that side of things. So the design patterns kind of like switch as you think about how the application is going to be built, as you think about how you're going to be using the AI there.
Yeah. So before I move to Aman, I think what you spoke about the context window and the whole stateless part of it, or maintaining the state. I remember, I mean, all of us, when we use any models now, and the moment you exceed a certain length of message or prompt that you're sending them, it immediately prompts that, hey, your chats are getting longer now. The responses will be slower, or things like that. And I remember some time back, I was working on a similar thing, and it's only when you actually get out from a hosted solution to building something on your own, that's when you realize the entire context window aspect of it, and then you realize that you have to spend that much amount of it every time. Where I was working on chunking, and then I realized, okay, hey, on the UI or a hosted version, it doesn't seem what's happening in background. But then when I'm implementing it, I realize that again, that's the chunk every time that has to go, and plus probably keep adding on top of it. So yeah, Aman is having a laughter, so maybe he has a story to share here as well.
Yeah, I think it happened in the same way. Like you said, when you start designing it, this hits like a first thing. Like it's so much data you have to send to make one right decision, and this is really good. I mean, this really changes your all the right sizing calculation, everything you have thought about. It's not like you ask it and it will just answer it. So it's not one way street. You have to give a lot of things to it to just get one accurate answer.
Yeah, and that's AI for all of you. You need to give it lots of information to get one particular answer. Now, we spoke about so many things until now. We spoke about the blocks, code building blocks. We spoke about system patterns, design patterns, and I think these all things eventually affect the performance of your model, right? And like Aman said earlier, nobody wants to be staring at a screen after giving a prompt. It just says loading. We are waiting for a response or anything of that sort, right? Everyone wants things to happen quite quickly. So, Craig, again, coming back to you, what are some absolute necessary performance optimization tips or tricks that you would want developers or teams to keep in mind when they're building such systems?
Yeah. So if you're building something where you're going to just interact and you want an answer to come back, and that answer might be something that a lot of people are going to ask, that is something that you could cache, right? And if you can cache, so you've seen this, right? So when you're looking at apps and there's little bubbles, it's like, I'm trying to do this thing, and there's the bubbles, it's the suggestion of the bubbles, and it runs through there. Those bubbles can be you can change whatever those bubbles are, first of all, like the most frequently asked questions, right? And those can be cached. And if you can get that to hit the cache, you don't even need to worry, right? On the other side of that, like you don't need to worry that it's not even hitting your AI system, right? So that's a good thing to do. Being able to spin up models, as the load comes up, that's like very important. And then also being able to, again, we're getting back to the routing stuff there, but being able to go and get that the model where you need it. I think that the understanding your load, right? Because as you build these apps, you're going to see that your daily load of things are going across at a certain time, and understanding that and going and saying, how can I make that better right here? And again, if you had GPUs in other places, how could you go and help with that? How can you inform the routing algorithm based on what's happening there as well? So yeah.
And I think absolutely important things that you have pointed out over here, especially on the whole aspect of moving things, shifting the traffic or load balancing aspect of it. And I think Casper over here has an interesting question, which I would probably want to take it up now rather than at the end, because I think we are at a right juncture to take this up. So Casper is basically asking, what are some patterns that you have found effective for handling model warm up and cold starts? And I think the cold starts is a problem, with a lot of things, not only AI systems as well. So both of you, what are some things that you would have come across or to address this particular problem?
Yeah, I think
Yeah.
many At the application layer, or if you think it from the fundamental perspective, that remains same. Any cold start, you need the actual server or the actual process to be at least alive or being warmed up or there in memory, right? So that remains same for even for models. If you want to run it, you probably can do like a one request or a test request every few sometime. That will keep the model in memory and load it in the inference servers, because inference servers also work in a different way. You have server, then you have model, models load on the server, and then they are served. And there could be different models, like we talked earlier, like it could be chain of models that you're using. So that those traditional things remain same. Data, like we said, it should be closer and should be more easily accessible. If you're spending more time on just getting the initial data, or if your GPUs are not that good, so understand what you're using, and like Craig earlier said, how you're using. These two visibilities are pretty necessary. So if it GPU in itself can't hold in memory your context, then you probably will have a lot of wait times, because it will have to again and again go back to the storage and then get your answers and all those things. So observe, and based on that, take decisions. What things work for you, what design works for you. But on the fundamental layer, it remains same as the traditional systems. Do test queries and all that works for you.
Yeah, great. Craig, anything from your side?
Yeah, I think it's an interesting question, because if you're thinking about making a platform where you host models to use, it's a little different than thinking about how your application is using the ones that you're hosting for yourself. So you the on the platform side of things, you can kind of watch. It's really interesting. This space is moving so fast that you can kind of watch the trends of the models of how they're going, right? So you can kind of, some of these models will fall off after people aren't using them anymore. Some people will build apps, and they'll, if you're running a platform, if you're running a hosted model platform, you'll see that some of these models will start to fall off, which is where you would probably see some of these cold starts. But it kind of just works. The effective on that platform is because the people are using the models, and the models are kind of staying warm. And of course, I'm simplifying the amazing work that the MLOps engineers have done, and models that are being most used are alive and warm for you. So that's actually the trick, is like, how do you anticipate how these models are going to be used? And we're in the place where you can do this with AI as well, of like, hey, this is probably going to be a place where we're going to need to have a warm model. Let's make that model warm, right? Like that's there's some science that's happening in there as well. And again, one of those things that I'm glad someone's thinking about it. You know what I mean on that? Like when you have these libraries that do the thing that you want it to do,
Yeah, right. I think more than science, I think it's more of an inception here as well, because you need an AI to observe your AI. So I think there's a lot of it going here. So yeah, I think we have had great discussions until now. I think we have had a lot more theoretical stuff. We discussed all the model building blocks that's required, the core components, infra, design patterns. And I think like a typical learning scenario, once you have done with learning something, it's necessary to implement it and see how things work. And that's where Craig is going to introduce us to Cloudflare's Worker AI, and tell us how we can implement all of these things to build a simple application, or even complex applications, using the Worker AI. So Craig, over to you.
Awesome. So yeah, so I want to introduce you to Cloudflare Workers AI, which abstracts away a lot of the stuff that we have been talking about here. A lot of these challenges that you would have been having to do. We have an MLOps team that has gone and thought about this, and we've built this global network of there's serverless GPUs, which we'll talk about here a little bit. I'll show you what that feels like. We have this global network, and if you don't know Cloudflare, we're on a mission to help build a better internet, and so we've taken our time to figure out what that means. And that means low latency, and that means security, and that means giving developers the ability to help build the better internet. And as we know, having access to a GPU is hard to have sometimes. So what we've done is we've built this system called Workers AI, and Workers is based on, we'll take a look at a couple of workers here. We'll build a little serverless application And what we're going to do is we're going to be able to access these serverless GPUs through a single API call. So we have an external one. So there's you can hit it through a REST API, but you can also hit it from within our network. So within this global network, you can hit it, and it's fast. No matter where your users are coming from, we're thinking about that. We're trying to make that latency. Think about where that is. And what we've done is we've partnered with open models. So everything that we're hosting are open models. So we're hosting open models. We're partnered with Hugging Face. So a lot of the models that you'll see. And if we could flip the next slide here, I'll show you. There's a bunch. So these are the docs here. We have a bunch of different tasks that you can do. When I was talking earlier about breaking down the task into things that you might want to do, there's models that are very specific to what you might be trying to do. So we got speech recognition. There's all sorts of models coming out. And we were talking before in the past. And I'll share a link to this here as well, so you can jump in here and click around as well. So it's really powerful, right? So we've got all these different ways of thinking about how to solve this problem in a small little model that's available for you that should be lightning fast as you go to use it, no matter where you're at. So that's the concept of what Workers AI is. Now, what it's doing is it's sitting on top of the Cloudflare stack. So if we could go to the next slide here. The Cloudflare stack is very powerful, and I'm loving watching this thing grow. I've been with Cloudflare for about a year, and just the amount of stuff that has come on since then. So there's a vector database, right? So one of the things that didn't come up too often actually in our talk there is that you have to get your data into these AI applications. We talked about that, and one of the ways that you do that is through a vector database, right? So you take your information and you store this in a vector database, and we have one of these there available to you, as well as we have this thing called the AI Gateway, which allows you to not only run models on ours, because we know that you're probably going to be using state-of-the-art models, but this is how you can watch and make sure that things are working there, right? So you can watch all of the queues coming through, and we can do evals, and we can build training sets from that, but everything pipes through this one place, and you can use it gives you a URL, so you can use it with all of the other applications that you're doing. So if you want to go get your data to go all through one place, which I think is probably honestly where we're going. We had this concept and we should probably run something through here because we have other gateways. Cloudflare provides other gateways, and it's been so right. Like every step of this AI journey that the whole world's going through right now, rapidly running through this, we've been saying, oh, we should just add that to AI Gateway, and it's been working really well. So excited for you all to see I'll show a little bit of that here in a second. We also have the whole data layer here, which we said was important, right? We said being able to store your data is super important. Being able to cache key value stores are really important for that. We also have D1, which is a SQLite database. It's distributed, so you can kind of get access to that from wherever you're at. We have R2, which if you increment both the R and the 2, you'll see that it is compatible with S and 3. So R2 is object storage. Now, the really awesome thing for AI, people to know about with AI is there's zero egress fees. So if you take data out, you don't pay for it. That's not true of most object storage places, and there's a lot of data. And so that gets really costly as you're going to train models. So that's a great place to store your training data. Compute, we've got workers. We'll take a look at that really quick. So it's a V8 isolate engine, which means it's always on. So back to the cold start question there. As far as the compute side goes, it is always on. It's wild. They're super fun to build. I'll show you that here. We have a queues product where you can just kind of go and you can do your data pipeline, right? So you can send stuff through there. On top of that, we have this thing called workflows, which just very recently came out. Durable execution, and it has timing, so you can do these steps at a time and make sure that they happen. So as we know, sometimes you run into these 429 errors if you're hitting an API, an external API. It will do exponential backoff automatically. It just does it, and then you just kind of say, go run this workflow, and it will finish, which is really, really powerful. And we have these durable objects, which we've been trying to figure out how to explain this. I'm going to try it really quick. So it's the tiny little server that you can spin up, and you can put them wherever you want to go. And it has access to WebSockets, which I think is getting more and more important as we see this. Again, what we were talking about earlier about I want to feel like something's happening. So they have a WebSocket, and then they can run, and it has its own SQLite instance. So it's its own little server, basically. It's incredibly powerful, and we really think that as you start thinking about agents and building agents and stuff, you're going to be hanging out in this space, in this durable object space. We also have real time. So we have the ability to do video calls and things like that. And we can do streams and images. And what's important to know is that all of this can be part of your AI stack, right? So this is all just kind of available and it feels really good. And let me show you how it feels. So I'm going to go and share my screen here.
Yes, and we have a demo coming up here by Craig. We looked at the Cloudflare stack that he pointed out, and the various features that it provides. And as a developer, I think it makes real good sense to try it out to build something like an agent, because you have all the features that are available for you. And I was just going through the website. They have a generous free tier as well, where you can try it. And I think Craig's screen is ready, and we'll just get it on screen. So yeah, here you are.
Awesome. So what I'll do is I'll just make a quick little, I'm going to make a quick little worker so we can kind of feel the flow of that. So I'm just going to do npm create Cloudflare at latest. And so it looks like it's npm, right? So it's very node friendly. And I'm going to make a new one here. I'm going to name it, we'll call this Hello World AI. And because you got to start at Hello World. We've got these templates. We have a whole bunch of frameworks that we support. So if you were going to do a web framework, you can go build a full app over here on a worker. So I'll just do this Hello World worker. We'll do this TypeScript. We'll get this going. And again, it's npm enabled, right? So like it's adjacent, I would say, node adjacent, but it's not node. So you're able to use the whole lot of packages that you're trying to do. So anything that's over in that space. We also have a Python worker as well. So I'm going to go ahead and I'm going to make this. By default it has Git, and I'll push this up when we're done as well. And do I want to deploy my application? Not right now. And so I'm going to go into my Hello World AI directory here, and I'm going to open this up in my editor. I've got a really nice template to get started here, and let's just take a look at the code really quick. It says Hello World, so let's make sure that we got Hello World running. I'm going to open this up. I'll make this a little bit bigger. It looks like we need to.
Yes, I was just going to say that. Yeah, looks perfect.
All right, sweet. So so it says Hello World. I'm just going to run. I've got a little server here. I'm going to do npm run dev. Very nice development environment. So it's going to ask me to if I want to open up a browser, and I do want to do that, and it's over here. Let me grab this real quick. So open up this browser. Hello World. We're doing the thing, and we want to now go back. And this is wrong, right? There's a typo here. It's actually a comma. So I'm going to do a save. Automatically reloaded the local server. I've got all the niceties now, and I refresh, and we have that working. Now, what's really cool about workers, what I really love about it is that I can go and deploy this. But let's make it a little bit quicker. I'm going to use one of my favorite packages. Just again, it's npm adjacent, so I'm going to use a web framework called Hono. I don't know if you've seen Hono, but it's incredible for building microservices. Have you all used Hono before?
Nope, I haven't. That's new for me. Anyone in the audience, if you have used Hono, please let us know. If you have not, please let us know again.
So I'm just going to type at Hono, and because I use it so much, and it's going to do this Git. We're going to do a Git, and it's going to go Git to hello. So it feels a little bit like Express. If you've seen Express, it feels similar to that. It's got these really nice. So we've got Hello World JSON here. Right, I'm going to go ahead and I'm going to now I can run this locally, I can start working on it, but I'm just going to go ahead and deploy it. I'm going to deploy it again. I haven't said where this should live. I'm just going to go and I'm going to deploy it, and I'm going to deploy it on my account. I haven't said where it's going to live, and I just deployed, and what happened is it just would deploy to what we call region Earth. Instead of US East 1, it's region Earth. It's literally everywhere. So this is up and running, and now I've got a URL, and you can see how fast that went. Right, and so now, I think I left it at hello. So I'll fix that in the next one. So /hello, we've got hello world invalid JSON, right? So now we've got a really nice quick microservice that we could go and do. But we're here to talk about some AI. So let's bring some AI into this. So we have this concept of bindings, and bindings allow you to talk to that stack that I was talking about. So one of the really nice bindings that we can do, let's make this. comments. So one of the really nice things that we can do is we can add a new binding here, and I'm just going to add this AI, and I believe, yeah, I want to do AI, and it auto completes, which is very nice. And I'm going to say binding is AI. So we're going to all I need to do to get that working now I'm able to, this is all TypeScript, so it will automatically generate a type for me, CF type gen. And now I have this interface that I can go. And so now I'm in here, I'm going to get back some results from this AI, and we'll say we want to do c.env. And now you see that I have AI here. And now I can run any model. So again, we're talking about that there's this one line. I've got all these models here. We'll just use, we'll use the llama. Let's use CF.
And all these models are coming from Hugging Face, the slide
all
that
these, yeah. All these models are Hugging Face based models. So we've got this one here from Meta, right? So Meta's doing that. And I'm gonna go and I'm just gonna really quick. We could do the messages array. Everybody knows the famous messages array, and all of the models we've made it so that it feels the same way, right? So we're going to do role, and we'll make the user say, yeah, let's have it say hello world in 5 languages. And you know what? I want to make sure that this is working properly. I want to make sure that I want to track this as it goes. So in order to do that, one way when you're using this, you can just add this new line here for this AI gateway. Man, it's so funny when you use the bigger screen. Those things stop helping. The pop-ups stop helping. So to say we're going to do gateway. Wait, hold on. So he's a CF run messages, and then I want to do. Hold on a second. CF messages. So run the messages array, and then I want to do. Yeah, there we go. Gateway, and then I'm going to give it an ID. It's too big. I'm not getting my autocomplete. It's funny. So we'll do. There's a gateway that we want, and that gateway has an ID, and that ID we're going to call this live demo. So and why is he upset? Oh, I don't need doubles there. That's what's happening. Is that what's happening? I think I do need doubles. Oh, I'm missing this start. That? Sorry. I've broken something. I'm not going to. I won't show the gateway. I'll show you a demo of that here in a second as we get to it. But we'll just get this run here, and I'm going to do this npm run deploy. And again, this is going to be this will be live here, and it's not streaming, right? So this is what this is. This is not going to stream, but it's still going to be pretty fast. So we're going to open the. Oh, I need to show the results. I didn't show the results of it. So we're going to pass in hello world, and I'll just pass out the results there as well, and then I will deploy this. Here we go. And it's gonna take a little bit because it's not streaming, but there we go. So we've got this response from a llama model that is there, and it says hello world. We've got hello out, and we've got alamunda, and yeah, we didn't get Urdu or Hindi. I wish that we did. I wish that had come out. But so we got hello world there very very quickly, and so again, what's powerful is with these bindings is that they keep on growing, right? So your powers grow there. Let me show you really quick one of the microservices that I wanted to demo here is this auto transcriber. So very similar. This is a worker, and I've created this worker entry point and it exposes these methods. This list uploads, get upload, and delete upload, and it's maintaining that, and it's kind of abstracting away the fact that I'm going to upload files. And so the files that I wanted to upload, I have this object storage, and I can just drop a file into my object storage, and it will go and grab that file. It will pass to the Whisper model, right? So now we're doing one of these pipelines. So I've dropped a file. It's going to pass. It's going to go to the AI model. It's going to generate the transcription for that, and then it will store the transcription in metadata. And again, so now we're talking about the caching, right? So I don't need to run the transcription every single time on this. I want to cache the fact that I have done this transcription. So I'll drop into I could drop a file. It will go and do an auto transcription, and then we'll have the ability to have this microservice that gives back the URL, and we can use that in other applications. So like I've built this wrapper around a whole AI process that can happen. I'll share this with you. I'm going to run this really quick. I'm noticing that we're running a little bit tight on time. Are we okay to go a little bit longer here?
Yeah, sure.
Okay. Okay, I'm gonna deploy this service, and I want to show you. So first of all, the gateway that I didn't get working because of my screen being too large is what I'm blaming it on that. You can very easily you say that I'm going to a certain gateway, and you can see how many tokens came through. And if you come in, you can look and you can see this is me testing beforehand. That it works, and you can see what I passed in and what happened here, and I can eval, and I can build data sets and all sorts of things. So this is the gateway that's there, and I can build that for specific URLs, and I can use those URLs. I know that you've seen in most of the SDKs, you can say use a specific URL, and you can pipe it through here, and then you'll have all the information here for you to build whatever new tools that you want to do there. So in my in that app that I have this I have a uploads directory there, and I'm going to show you. I'm going to tail the logs here so we can watch this go really quick. And I'm going to take a file from my local system here. What can we grab here? Let's grab, I have just a little robot that was talking that says brought to you by Cloudflare. So we'll drop this into my bucket here. And this is wired up to a queue that's going to go and we'll send that information through, and it should catch it in this transcription here. And I've got a bug. As you do.
Demo
gods are not happy right now. So I'll need to figure out what that is. I recently just changed this to be using a new package, and I think I broke it as I did that. But all that to say,
yeah,
you got the idea. It came through. It triggered that. It triggered my code, which happened to have a bug, and now I'm able to go. I'll go and debug that as well, and then I'm able to use in the other code, in my other code, I'm able to use this microservice. And what's really cool about these entry points is I'm going across the internal network, and I'm not using a REST API. I'm actually using it specifically. So I've made a binding that's very similar, right? This binding here is very similar to the AI binding. I've made my own binding, and I can call list uploads, and I can extract all that stuff and pull it into my other applications. And I can use this microservice for any sort of app that I want to. So I would bring the file in there, and it would go and update there. So that's the concept of and what it kind of feels like. And also, again, what it feels like building here. Why the microservices are important, right? I could be working on this microservice that handles these uploads, and there could be one that's working already, right? It's working already, and I'm sitting here fiddling with it where I was fiddling it to do this buffered code, because the code to make something base 64, I was trying to simplify it right before I started here, and that's not what you should do right before you do a demo. And I broke it. So that's what it feels. It basically feels awesome, and it's fast to work here. And the Cloudflare stack has all of this wonderful things that you need to build a modern AI application. And it's really fun and fast. And we'd love for you to do just that. There is a link that we have for this. We'd love for you to come join the community or our Discord if you're interested in learning more. Take a look at all of those models that we have there, very generously priced. We have a great free tier too, so you can kind of sign up without a credit card, start working through all this stuff, and we'd love to hear from you. So join the community, and there's docs there. The link for the docs there is to go start exploring, developers.cloudflare.com. Come hang out. We'd love to see you. Thank you.
Yep. Thanks a lot, Craig, for that. Nice demo. I think it was very easy when you showed how to just pull in a model and then just have a construct in place and get everything working. And even the way everything else is tied so neatly with the entire offering, I think that will make lives much easier for anyone to basically reduce their time to market. You have everything in one place, whether it's R2 or whatever, and then get it working. And on a personal note, I use Cloudflare for my website, not the AI part. Obviously, the other things. I am a Cloudflare customer myself as well. But then I'll probably try this out. While we move on to the final stages, to the final questions, I think there was one in the comments that I saw, which is Craig for you. And I think it's fairly straightforward. What are the audio files that are currently supported? Is it MP3 or what?
Yeah. So the files are this is the Whisper model, and it supports MP3 and WAV, and I think it even supports MP4. So you could also people use the Whisper model to do transcriptions for videos, right? So what comes back, which I was trying to show you, but I broke it, is an actual transcription of timestamps. So you can use those timestamps to build really nice applications on the other side where you could click the word and it will jump to that point in the video, that sort of thing. Because it's timestamped, right? So you can wire the thing together. It produces a VTT as well as the text of what the person said. And voice is getting more and more important for that. And so I would expect to see, and again to the point that we were talking about earlier, these models are going to evolve, and we will have a text-to-speech or a speech-to-text model, automatic speech recognition model that will keep on the best of the best will be there, and it will be doing whatever it is that we want to do as fast as possible. That model is really fast. I wish that it didn't eat. It didn't fall in its face there at the end because of my code. It wasn't actually the model code; it was my code. So it's super fast how quick that can go and how big the files can be as well, right? So you can upload large files there, and it can go and process that. So super neat.
Yep, interesting. I think one exercise that we could probably try would be taking this video and using the worker AI to transcribe it and have the timestamps done for this. So maybe let's see if that's something that I do. I'll probably share my learnings of doing that. So with that, we come to the end of today's webinar. We stretched it by some time, but I think it was really fruitful because we had some really in-depth discussions around how do you build and manage AI systems, and then actually getting deep into the system aspects of it, the designing aspects of various modules, and eventually the demo that actually showed how you can use Cloudflare Workers AI to get things up and running. So thank you so much, Craig and Aman, for your time. It's been a wonderful discussion, lots of learning for me, and I'm sure a lot of our audience also learned quite a bit from this webinar as well. So yeah, before we sign off for today, we'll have a lot more webinars lined up. So please scan this QR code and subscribe to any upcoming webinar. And with that, the three biryani lovers will take a leave for today. And please follow us on socials. Please follow Craig, Aman, myself, InfraCloud, Cloudflare to see what are the exciting things that we all are doing. So with that, see you all on the other side. Thanks once again, Craig and Aman.
Thanks, everybody.
Thank you. Bye bye.